Use the function below to answer the following questions. F of x is equal to x squared plus 1 over x plus 4. So the first question they ask us is 1, 2/5 on the graph. All right, so let's plug 1 into the function. So we're going to put this in for x, and we're going to see if essentially we get the answer 2/5 when we're done doing that. All right, so f of 1 would be the same as saying 1 squared plus 1 over 1 plus 4. And when you do that, you end up with 1 plus 1 over 1 plus 4, or in other words, 2 over 5. And that is the number that they said we should get. So essentially, this point is on the graph. So our answer for this question then is yes. All right, let's go to part B. Part B says, if x equals 0, what is f of x? Well, if x is 0, then we're plugging in 0 in for x here. So every place we see an x in the function, we have to put a 0. And of course, that'll just give you 1 over 4. So the answer is that f of x is equal to 1/4. If we write that as a point, we can then go ahead and say that the point is 0, 1/4, right? Because when x is 0, y is 1/4. All right, let's look at question C then. It says, if f of x is equal to 1/2, what is x? All right, so what we want to do is substitute 1/2 for f of x this time. So we'll say 1/2 is equal to x squared plus 1 over x plus 4. Now, in order to solve this, we can simply bring the 1/2 over to set it up as a rational equation where it's set equal to 0. So we'll have x squared plus 1 over x plus 4 minus 1/2 is equal to 0. Now, from here, it's helpful to get the common denominator for the function. So we'll say the common denominator is 2x plus 4. So we're simply going to multiply everything in the equation by 2x plus 4. Okay, so now when we do the multiplication, the x plus 4s will cancel out here, giving you just 2 times x squared plus 1, minus here the 2's will cancel out, giving you basically negative 1 times x plus 4. And that's equal to 0 times anything here will just be 0. Then from there you have 2x squared and plus 2, then minus x, and minus 4 by distributing, right? And then finally combine like terms. So we'll have 2x squared, the 2 and the negative 4 make negative 2. So we'll have negative x minus 2 equals to 0. And that provides us with a quadratic that we can try to solve. So we should probably try the quadratic formula on it because it does not look factorable. So we'll say, okay, let x be equal to the negative of the b term. So that'll be negative 1, or in other words, positive 1. Plus or minus the square root of the b term squared. The b term here is negative 1, so we'll square that. Minus 4 times the a term times the c term, which is negative 2, all over 2 times the a term, or 2 times 2. Right, cleaning up that arithmetic a little bit, we end up having 1 plus or minus the square root of, it'll be 1 plus 4 times 2 times 2, or in other words, 16. The reason why it's plus is, remember, we had 2 negatives there. Negative 4 times negative 2 gives you positive 8, and then 2 times that gives you positive 16. And of course, that'll all be over 4. So continuing with the simplifying, we get 1 plus or minus the square root of 17 over 4. So we end up having 2 answers here. They're not the prettiest answers in the world, but they're 2 answers. I'm going to write them as points now. All right, so the points will be 1 plus the square root of 17 over 4. Comma 1/2. Remember where the 1/2 is coming from. This is the value they said we would have for f of x. And remember, f of x is like the y in our point. The second point would be 1 minus the square root of 17 over 4, comma 1/2. And those are the 2 points that have a y-coordinate of 1/2 on the graph of our function. All right, so question D says, what is the domain of f of x? So for the domain, you have to think about what are the acceptable x values that can go into the function, right? And when we think about that, we have to think about what could cause problems, because usually any x value would be okay in the function. There are some exceptions, however. You don't want to have a situation where something under the radical becomes negative. You don't want a situation where the denominator of your fraction becomes 0. Now, in this function, we don't have to worry about radicals because there are no radicals, but we do have to worry about the fraction issue, right? We do not want the fraction's denominator to end up being 0. So what we want to do is set the denominator equal to 0 and figure out what x values to avoid. So if we have the denominator set equal to 0, we're basically saying x plus 4 equal to 0. And that is easy to solve and find that x is equal to negative 4. In other words, that's the value that will give us a problem, right? So x cannot be equal to negative 4 because if that happens, the denominator will become 0 in our function. So we're simply going to say that x is such that x is not equal to negative 4. In other words, that is the domain for the function. You could also write it using interval notation. That basically means that the answer is from negative infinity up to negative 4, but not including it, and then pick up again at negative 4, but don't include it, and go all the way up to positive infinity. So all of these x values will work. All right, let's look at the x-intercepts then. For part E, the x-intercepts are basically going to require us to set y equal to 0 and solve for x. So if we do that, it's actually not too bad. We'll have 0 for f of x is equal to x squared plus 1 over x plus 4. So let's just point out that the only way you can get a fraction to have a value of 0 is if its numerator is equal to 0. So really, to solve this, all we have to do is set x squared plus 1 equal to 0 and see when that's going to become 0. However, when you actually do that, you'll see that it's going to give you x squared is equal to negative 1, right? And something squared cannot give you negative 1 unless that something is an imaginary number. Imaginary numbers don't appear on our graphs because our graph uses only real numbered values for x and y. So because of that, there will be no place on the graph where the graph crosses the x-axis. So there are no x-intercepts. Okay, and let's do the last step here, which is the y-intercepts. So for the y-intercepts, this time we set the x values equal to 0 in the function. So we're basically finding f of 0. And we actually already did that, but let's do it again one more time. So we're trying to figure out what f of 0 is, right? Because if you plug 0 in for x, you get the y-intercepts. And when we did that before, we ended up having 0 squared plus 1 over 0 plus 4. And we saw that our answer was 1/4. So in this case, again, the y-intercept is the point 0 for x and 1/4 for y.